Wait, your head is not even in the video.
Are we ready?
Yeah, but your head is not like.
My head's not showing, so
Yeah.
can you like angle it up a little bit? Because it's like my belly or my crotch, and you know, and I don't know. We don't make those kind of videos. All right. So sorry. Awkward start. So today's lesson is all about the fundamental theorem of calculus. And anything in calculus that gets a name is important. It's going to get used a lot. And I'm not always going to say, oh, we're going to use the fundamental theorem of calculus. You just need to know that it's time to use the fundamental theorem of calculus. Other theorems that have names include what? Other important theorems. The MVT, which stands for what? The mean value theorem. Way to get in there, like, I wasn't ready for that. The what? The Pythagorean theorem is not a calculus thing. That was an 8th grade thing, but it has a name and it's your birthday, so we'll count that. The MVT, the mean value theorem.
IVT.
The IVT, which stands for the intermediate value theorem. The L'Hopital's rule has a name. It's important. Now you're just showing off, Mr. like person from the future who just said the second fundamental theorem of calculus. The extreme value theorem, which is known as the EVT, right, Andy? All these things have names and give us certain things about functions, certain relationships, but I don't want to start that. In honor of my 4th grade daughter, I'm going to give you all 4 minutes to do 4 4th grade questions. This is a little bit of calculus fiction. Moving forward, every time I ask you a question and you answer it correctly, you earn 75 cents. This is calculus fiction. I don't have the money to pay you 75 cents every time you answer a question correctly. I would go broke. It would be good encouragement. I can't afford it. I've got 2 of my own. So 4 minutes, 4 questions. And now 4th graders wouldn't actually use a calculator on these questions, Sylvia. But if you need to, feel free. 4 minutes, show me what you can do. Get any of them wrong, we will mock you forever. I'll call you out by name on video. Okay, I'm going to push it back a little bit. Yes. Thank you. Let's assume Fabrizio answered all the questions correctly. And this word accumulated, if you're not sure, means like earned. He earned. How much did he earn? The calculator if you need to. I won't tell, Sylvia. I won't tell. 8 times 75 cents. Who knows what that is?
Oh my God.
Won't get a job at Walmart if you can't figure that out. Show me the work. We're in 4th grade. I have to see your work. I want to see your setups. Julissa is doing a great job.
7 times 6. I really don't know what to do.
Yes, I guess. I don't know why I'm not good at but I'm really good.
7 times 7 is 51. 8 times 7.
Is it 150 plus? $8.
Let's show you work.
It's $6, right? Okay.
After my 5 times tables, I'm just like, we'll go to X.
All right, 4th graders, you've got 1 minute and 52 seconds. We'll have snack time in a little bit. No nap time in 4th grade. Nap time ended in kindergarten. And I used to teach kindergarten. Oh, I love nap time.
Oh, wait, did you do the hand?
Oh, I needed nap time.
She walked out $14. She was great.
Oh, that was $14.
Little girl named
No. Also never got a kid breaking an arm window. It was the day that I took off from work that the arm was broken. And the day that I didn't go on a field trip that a kid got not lost, replaced. They took some other kid home. And left one of the other teacher brought the wrong kid home.
I thought I'm happy to
So you brought 28, but yeah, but only 27 are ours.
How did the kidnapped speak of?
They're in kindergarten.
15. I got 975.
I can feel the sense of fear in the room. Aaron's like, if I get any of these wrong, I'm doomed.
Oh, wait. I made a mistake. No. You're supposed to divide.
All right, here we go. Fabricio answers 8 questions today. He will have accumulated. Sylvia, I don't care. I care about what the answer is, but I care about your process. So tell me about this first one. What did you do?
I multiplied
Yeah?
8 times 75. 0.75.
0.75. Good save because we're in 4th grade. So you took 8 times 0.75. Now this is 75 cents per question. And 8 is the number of questions. Now someday this will make a lot more sense because you'll be in a calculus class. But someday someone's going to tell you that the 75 cents per question is a rate. What's that word again?
Rate.
Way to go, 4th graders. So you're earning at a rate of 75 cents per question. You answered a total of 8 questions correct. You multiply those together and you're going to get $6. Way to go. Sylvia, calling somebody else.
Rebecca.
Rebecca. Victoria enters the class with $3.50 in her wallet. She answers 6 questions correctly today. She leaves the room with how much in her wallet? What did you do?
I multiplied
0.75 times 6. 0.75. Hey, that rate is getting multiplied again. It's the rate times the number of questions, but that wasn't the end, right?
And then added $1.50.
And you added on to this $3.50. What'd you get for a final answer?
$8.
$8. How many guys got $8? Okay, good. Well, now let's see. This 75 cents, what did we call this?
Rate.
That's the rate. I have a fancy word for this $3.50. I'm going to call it, not a constant, 4th grader. Shh, I'll call your parents. The $3.50 is the initial value, or it's your starting value. Your initial value plus your rate times the number of questions gives you this $8, which we're going to call the final value. All the friends are okay? The initial plus what you earned or what you accumulated is equal to the final value. All right, Rebecca, calling somebody else. Gonzalo, what'd you do for number 3?
Hold on. I got it.
The mic.
Jose ends the class with $9.50 in his wallet, assuming he answered correctly 7 questions. How much did he have at the start of the class period?
So I subtracted, no, I multiplied 0.75 times 7.
Okay, 0.75 times 7.
And then after that, I subtracted.
Wait, you subtracted after that?
I added.
You added after that?
No, I did subtract. No, I did subtract.
You did subtract, but I don't think you did this minus.
Oh, no, I did. The initial value minus.
So you did that minus that?
Yeah.
And what did you get?
4.25.
Okay, but if we say it like a 4th grade educated kid, you're going to say $4.25.
Yeah.
Okay, this is the rate. The $9.50, Gonzalo called it the initial value. Do you guys all agree it's the initial value?
No.
Read the question again.
Final.
It's the final.
It's the final value. Right, the 950 is what he ended class with. That's the final. Here's the accumulated amount. And the $4.25 is the initial. It's what you started the day with. Okay, Gonzalo, call on somebody else.
Adrian.
Adrian. Cynthia entered the class with $4.25 in her wallet. If she left the class with $14 in her wallet, how many questions did she answer correctly? How would you solve this problem?
You would subtract $4.25 from $14.
Okay, excellent. So you said subtract from, and now I know that whatever you say after the from goes first. So 14 minus the 425, okay?
Yeah, then you would get $9.75.
$9.75.
Yeah, and then you'd divide that.
Yep. You're going to divide by the 0.75.
Yeah,
And what'd you get?
and I got 13.
13 questions. And just as a quick vocab moment, one more time. The $14 represented what? $14 represented what?
Final value.
Final value. The 425?
Initial.
425 is the initial. This 975 is what you accumulated. It's what you earned. And then we divided by the rate to get the number of questions correct. Is everybody 100% correct in 4th grade mode? Congratulations, you've been promoted to 12th grade now. You're going to talk. No! Some of you were starting to smell like 4th graders. It was getting a little scary. It was getting a little scary in here, but here comes the fundamental theorem in calculus, and this is, I promise you, no harder than what you did way back in 4th grade when I was your teacher. It's no harder. So you're like, you weren't there? Jeanette, can you read the introduction? According to your textbook?
According to your textbook, the fundamental theorem of calculus states if f of x is a differentiable function on the interval a, b,
Then something, right? Okay, differentiable, it's been a while, but you guys know differentiable means what? We're in 12th grade, not 4th grade.
derivative exists.
The derivative exists. I heard continuous from Destiny. Continuous and derivative exists. No longer in 4th grade, that's for sure. Here's what the fundamental theorem of calculus says. Let me write it and then we'll talk. It says that f of b is equal to f of a plus the integral from a to b of f prime of x dx. F of b equals f of a plus the integral from a to b of f prime of x dx. You know this already. You've known it since 4th grade. F is the function that we're talking about. F prime is the derivative, right? The f prime is a rate. It tells you the rate of change of f of x. When I take that integral of a rate, we talked about this last week when we were doing like the definite integral as a measure of change. When your function, when your integrand is telling you a rate, when it's telling you how fast, maybe it was how fast water was leaking out of the pool, maybe it was how fast your position was changing, what happens with the integral? If this is how fast, when you integrate it becomes how much. This is how much your function changes. So how much the function changes from a to b. Well, f of a is the value of your function at the very beginning. This is your initial value. If I take the initial value of my function at a and I add on to that how much the function changes from a to b, you know what I'm going to get? You're going to get the final value. So just like that example from 4th grade that you may remember from like 8 years ago, your final value is your initial value plus how much the function changed. How much money you had at the end of the class was equal to how much money you had at the beginning of class plus how much you earned during class. Are we okay?
Yeah.
This is the fundamental theorem of calculus. That's it. The whole thing. Ta-da! Now, some textbooks are going to write it this way. They're going to say the integral from a to b of f prime of x dx is equal to f of b minus f of a. Have a quick conversation with somebody near you and explain to them if these are the same or if they're different. If they're the same, explain why they're the same. If they're different, why do you see that's different? All right, friends, what do we think? They're the same or they're different? They're the same. That seem pretty consistent. They're the same. Andy, do you agree that they're the same? Andy, why is it that they're the same?
Because just switch.
How did I switch? What did I do?
You subtracted the f of a.
Subtracted the f of a from both sides?
Yeah.
Is that legal?
Yeah.
Legit, we're okay with this, right?
Yeah.
Okay, fundamental theorem of calculus says that the final value is equal to the initial value plus how much the function changes from a to b. Say that with me a couple of times. Fundamental theorem of calculus says the final value equals the initial value plus how much the function changes from a to b. Okay, one more time. The fundamental theorem of calculus says the final value is the initial value plus how much the function changes from a to b. Everybody good with this?
Yes.
All right, Paul, can you read those last two paragraphs?
F prime of x represents the derivative, also known as the instantaneous rate of change.
So far so good. And then you reach that sign and you say,
Represents the accumulation of all of these changes.
no. This notation over here, Paul, that you're refusing to read. It's also on your paper, so you don't have to read it off the board.
Oh,
The definite integral.
the definite integral of f prime of x with respect to b of x from x subtraction x equals a x to the
Yeah. Keep going.
represents the accumulation of all these changes, total change or net change on the integral f of b. Furthermore, f of a represents the value of the function at the start of the integral, and f of b represents the value of the function at the end of the integral.
And everybody's okay with this. Okay, wrap it up.
The fundamental theorem of calculus establishes a connection between a function and its derivative. This is going to be super helpful in problems involving rate function, physics applications, etc. I expect to see this a lot in the future.
All right, for the next couple of problems, I want you guys to have your calculator out. You don't get to use your calculator for the first one, but you're going to want it for the other ones. So just like the IVT and the EVT and the MVT and all these other L'Hopital's rule, rarely is the College Board going to say, or will I say, using the fundamental theorem of calculus, do blah, 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 blah. Okay? Rarely am I going to use the words. You need to be on the lookout, though, if the fundamental theorem of calculus says f of b equals f of a plus the integral from a to b of f prime of x dx. They're going to give you some of the pieces, and then you have to figure out the other one. So let's look at this first example. The figure to the left shows the graph of f prime, where f prime is the derivative of f, on the interval -1 to 4. F of 0 is equal to 1. The graph of f prime consists of 3 line segments and a semicircle. Find the values of f of 4 and f of -1. Show the work that leads to your answers. At no point have they said fundamental theorem of calculus. But what did they give you in the problem? They gave you f? They gave you an initial point. Where are you seeing as the initial point, Diego?
F of 4, it gives us 2 points of f of 4 and f of -1.
Well, but here's the thing. They haven't given you f of 4 and f of -1. They're asking for that. What did they give you, though? They gave you some point f of 0, and they gave you something else.
The graph.
They gave you the graph. What's this the graph of, though?
F prime.
F prime. So they gave you a point. So I'm going to say that this is the initial value. And then they're asking me for f of 4. Let's find f of 4 first. F of 4 is what I need. I need this part on the function. This is not the graph of f, this is the graph of f prime. If f of 4 is what I need, I'm going to start with what I know, which is f of 0. F of 4 is what I want, f of 0 is what I have. This is where I'm ending, this is where I'm starting. The fundamental theorem of calculus says that this value equals this one plus an integral from where to where? From a to b, from 0 to 4, from where I start to where I end. This guy is your final. This is your initial. This is the point that I know. The final is equal to the initial plus the integral from 0 to 4 of f prime of x dx. That's the setup. That's the fundamental theorem of calculus. Now you need to use your calculus skills. Well, if f of 4 is equal to f of 0 plus the integral from 0 to 4 of f prime of x dx, how are we going to find that integral? You have it?
You have the graph.
You have the graph. This is the graph of f prime. How would I ever figure out the integral from 0 to 4 of f prime of x dx if I have the graph? I'm hearing it from a lot of folks. Area. I'm asking you to find the area from x equals 0 all the way to x equals 4. So you need to find that area, you need to find that area, you need to find that area. Okay, well, what's f of 0? F of 0 is 1 plus I need the area. Area for the first shape, well, that's a triangle. So I'm going to do 1/2. The base is 1. The height is 2. Half base times height. How about the semicircle? Area of the circle is pi r squared. This should be 1/2 of pi r squared. Well, what I need to know is what's the radius. Let's see, the radius, if that's a semicircle, looks like it has a radius of 1. So 1/2 of pi times 1 squared. I want to be careful. We're below the x-axis, so it has to count as a negative. Okay, we got 1, we got 2. Give me that last one. Area of a triangle, 1/2 times 1 times 1. Okay, that's your final answer. If this is the free response, you can stop. But let's simplify. So I've got 1 plus 1/2 times 1 times 2 is 1, minus pi times 1 squared, well, that's just pi. So it's pi over 2 plus 1/2. That's good. 1 plus 1 plus 1/2 is 5/2 minus pi over 2. I like that. Even better answer, 5 minus pi over 2. Done and done. And that would be your final answer. That 5 minus pi over 2 represents f of 4, the value that I was after. Are all the friends mostly okay? All right, so the next part, find f of -1. Well, how do I get f of -1? F of -1 is equal to f of 0. My final value is equal to the initial value plus an integral from where to where? From 0 to -1. This is A, this is B, this is A, that's B. And I think some of you are starting to realize that there's a problem here. Okay. How many of you guys realize that there's going to be a little bit of a problem here? I heard some folks, Andy sees it. Andy, what's the problem? Isn't it what? Not -1 to 0. F of -1, that's what you want. F of 0 is what you have. So this is A and this is B, so this is A and this is B. But there is a little bit of a challenge here. Nothing super hard. Marilyn, what's the thing? Well, the fundamental theorem of calculus says f of b equals f of a plus the integral a to b. Okay, I think you're focusing on like the 0 and the -1. We don't like them in that order. So if you switch it, if you say, we'll put the -1 down here and put the 0 there, something else has to happen. You're going to have to subtract because of that. Which is, I know what you were getting to. All right, so what's f of -1? F of -1, f of 0 is still 1. Minus, I need the area from -1 to 0, not too bad. 1/2 times 1 times 2. We get 1 minus 1, which is 0. So that's f of -1. Fundamental theorem of calculus, final value equals the initial value plus the total change. You just need to make sure you have 2 of the 3 pieces. All right, so with that said, working in your group, see what you can do with problem number 2. Number 2 is calculator active. Oh.
0 for f of x such that f of 1 equals -4 if f prime of x equals x times cosine of x minus that is pi and f -1.
The f of 1 equals -4 doesn't initially.
Calculator active.
How do we know that this is not the initial Listen.
Yeah.
How do we know that this is not the initial?
Well, because this is the function. When we say the initial, you're looking for like a number or a value. Okay? We know f of 1 is equal to -4. We know f prime. I need f of pi. So you and your group are moving in a good direction. If what you're saying is that f of pi, which is what I want, well, what's it equal to? It's going to be equal to f of 1. This is your initial value plus your integral from 1 to pi of x times cosine of x dx. Your final is equal to your initial plus your total change. Here's how many of you guys have this as your setup. Okay, so in a good number of folks, f of pi, f of 1 plus the integral from 1 to pi, x times cosine of x dx. Your calculator does all the work now. You put it in one step, in one move. What are we getting for a number? Come on. -4 plus the integral from 1 to pi of x cosine of x. Your calculator's doing all the work for you. Hi, Kevin. Wrong class period. What are we getting for a number?
Negative 6.3.
Negative 6.302. That took a ridiculous amount of time for me to find 3 people that had negative 6.302. Okay. F of negative pi. F of negative pi, I'm going to start with my initial value again, plus the integral from 1 to negative pi of f prime of x dx should also be negative 6.302. It is just the nature of how this particular function was built. Where's the function? How that derivative was built. Don't overthink it. This is not something that's going to happen a lot. It is just a rare event because of how this function was built. Negative 6.382. Our other folks get negative 6.382. All right, negative 6.382. Fine. Okay, for all of the friends who, for whatever reason, did not have their calculator today, this cannot happen again. Not today, not tomorrow, not ever again. We're using the calculator every single day. All right, so let's keep pushing. Problem number 3. A particle is moving along the x-axis with velocity modeled by a differentiable function v. Selected values of v of t are given in the table above. The initial position of the particle is given by x of 0 is equal to negative 4 meters. Use a trapezoidal approximation with 5 subintervals to estimate the position of the particle at time t equals 32. Show the work that leads to your answer. Welcome to physics. At no point have I used the phrase, use the fundamental theorem of calculus to figure this out. This absolutely is a fundamental theorem of calculus question. Why? Julissa, what do you say?
You're given the initial position.
You're given the initial position, x of 0 equals negative 4. Okay.
And with the chart, with the values given in the table,
Yeah.
you can find the intervals.
You can find, well, these are velocity values. Do velocity and position have anything to do with one another?
Yes.
What do they have to do with one another?
If you find the area for velocity, you get position.
If you find the area for velocity, I disagree with you. If you find the area underneath velocity, you do not get position.
Displacement.
You get displacement. Why? Well, that's because velocity, if I start with position, how do I go from position to velocity?
Slope.
It's the derivative, it's the slope. So they gave me velocity information, but velocity is derivative of position. It's telling me, velocity is telling me how position changes. They gave me an initial value, okay, and they're asking me for the position at time t equals 32. That's your final position. Well, what does the fundamental theorem of calculus say? It says position at 32 is equal to position at time 0, my final, equals the initial, plus what? Plus the amount of change. Final's equal to the initial plus your change from 0 to 32 of, I'm going to write it this way so that it looks just like your fundamental theorem of calculus. F of b equals f of a plus the integral from a to b of the derivative. It has to be the guy here is the derivative of this function out here. All the friends are okay? Derivative of position is what? The derivative of position is velocity. So I'm going to take my initial position, which is negative 4, plus the integral from 0 to 32 of v of t dt. And here's where things get maybe a little bit tricky. How do I find the integral?
The sum of all the.
Well, the first one we did, we looked at the graph and we found the area. The second one, how did we find that integral? We plugged it into the calculator. How are we going to find this one, Andy? You're going to use the points because these are the points on your velocity graph. And that's how you're going to find the integral. So if you need to, if you want to take a little bit and plot the points so that you can get yourself a visual, feel free. Here's 0, -5. Here's 5, -1. Here's 13, 6. 20, 10. 22, 2. 32, -3. Whatever, you got some points. How are we going to find the area? What do they tell you to do in the problem? Trapezoids. I need 5 trapezoids. Every year I get to this problem, and every year I think, gosh, I got to change this one. For any of the calculus teachers paying attention, I don't like the fact that we've got some endpoints above the x-axis and some points below the x-axis. It's going to be a little bit confusing with the trapezoids, but let's see if we can figure out the pattern. Trapezoid 1, 2, 3, 4, and 5. Let's get some hands in this. What's the area for the first trapezoid? First trapezoid. Gonzalo, how are you going to find it?
Okay, 1/2
1/2.
would be f of 0, t of 0,
Careful, not F. There's no F here.
b of 0,
V of 0, what's V of 0?
-5,
-5 plus
-1,
plus -1 times base 1 plus base 2. What's the height? The height is
5.
the distance between the 2 points, so what's the height?
5.
It's going to be 5. That's that first interval. Plus, Axel, how are you feeling about the second trapezoid?
1/2
1/2
times
-1
plus 6
plus 6
times
times. I disagree with 5.
8,
Look at the points in the table. You're going from the point 5, -1 to 13, 6. The y values represent your bases. The height, you're looking for the change here. So that's a change of 8. They're 8 spaces away on the x-axis. Jeanette, how are you feeling about that third trapezoid?
-4.
Wait, hold on. Area for the third trapezoid.
1/2
1/2.
times.
How long is the first base? Remember the length, that's like these guys over here?
Is it 1?
Or not going to be 1. If you're at 13, 6, the 6 represents the base. So you've got a base of 6 plus what's the second base? You're going from 13, 6 over to 2010.
4.
The bases are how long the sides are.
Oh, 7.
10, right? So base 1 plus base 2 times the height is the distance between the 2 points. You're going from 13 to 20, so what's the height?
7.
7. Plus the fourth one, Karina, what's that fourth trapezoid going to be?
1/2.
That fourth trapezoid, you're going from 2010 over to 22,
10
10
plus 2
plus 2
times 2.
times 2 plus, let's get that last one, Paul. Fifth trapezoid.
plus 1/2
1/2,
2 plus -3
2 plus -3
times
times what?
10.
Times 10. And whatever that works out to be is your final answer. We don't have enough time to actually spend all the time on the computations, unless did somebody already type it into their calculator? No. Okay. What are the units going to be?
Meters. Meters. No meters.
Think about what we're measuring here.
Meters.
What you're measuring is, you're finding the area underneath the velocity curve. What I'm asking you for is position. The position at time 32. This is going to be whatever the numbers are. Meters. Okay, I definitely need to change this question. All right, last part. Using the information in the table, determine the value of the integral from 13 to 32 v prime of t dt, and explain the meaning of your answer in the context of the situation. This is our last one, and we're gonna be just fine. I want the integral from 13 to 32 v prime of t dt. What is v? V is, no. What is v? Velocity. Velocity is saying, how fast does your position change? What about v prime? It's acceleration, but what does it measure? Like if I asked you to explain acceleration, you'd say how fast what? How fast the velocity changes. Right? V prime is a rate function. How fast your velocity changes. So what is the integral? If v prime is how fast your velocity changes, this is how much the velocity changes. Be specific. How much the velocity changes, be specific on this. From a place to a place, from where to where? From t equals 13 to t equals 32. How much does the velocity change from 13 to 32? Don't overthink it. How much does the velocity change from 13 to 32? Well, at time 13, the velocity was 6. At time 32, the velocity is -3. How much does it change? How do we figure out change? It's just final minus initial. And I want to be careful because I keep hearing 9. It's not 9. Final, which is, what do we say, -3? Minus initial, which is 6. So it's going to be -9. And what are the units?
Meters per
This has to be, is it meters? Not meters per second squared, just meters per second. Because the question is, how much does the velocity change? Tonight's homework, it's assignment 80, and if I didn't make this clear, it's option number 1.
I'm